So I'm going to fly through this, so check your homework. So we learned yesterday how to do concavity and points of inflection. The directions for 1 through 4 is determine the open intervals for which it is concave up and down. What did we say yesterday? The second derivative tells you where the original function is what? Concave up and concave down. But it also tells you where the first derivative is increasing or decreasing. Okay? So I'm going to write all that out. So here we go. The first derivative, so check your answers, would be 3x squared minus 12x. Okay, then I don't even need to set my first derivative equal to 0. I am not doing the first derivative test, which we covered yesterday for maxes and mins. Actually, let me do one. I'm going to do one whole through in a minute when we start your assignment, so I'm not going to do it yet. So I'm going to go straight to the second derivative. We're not even doing critical values for the first derivative because I didn't ask for increasing and decreasing for the original function. I'm talking fast today, so you got to keep up. All right, so I'm going to do second derivative. We're going to get 6x minus 12. I'm going to set that equal to 0 because critical values is where the second derivative is equal to 0 or undefined. How can I rule out undefined before I even start? It's a polynomial, and there's no zeros in the denominator or anything weird. So we're going to get, I'm going to solve fast, so keep up here. So I'm going to get x equals 2 because I can do that math in my head. Now I do a sign analysis. It's going to be from negative infinity to 2 to infinity. This is a sign analysis for the second derivative. It's a sign analysis for the second derivative. I'd label that on my big assignment. You can use SA to do it. All right, so sign analysis for the second derivative. You use the second derivative equation. It's not factored, but it's easy to test. It's a linear. It's positive linear, so you know it's going to be negative positive. Everybody realize it's a line going uphill. It has to be negative positive. It has to be below above. Like, I don't need a test value for this one.
I can see that.
But if you needed a test value, Callie could say, I could test 0, plug 0 in. 6 times 0 is 0. 0 minus 12 is a negative. So what does this tell you? Okay, Teo, this tells me the second derivative, if it is negative, it tells me the first derivative is decreasing and increasing. And wherever the first derivative was increasing and decreasing is where the original function's concave up and concave down by definition. But we go to the second derivative to determine that. So all we're doing is saying where the second derivative is negative is where I'm concave what? Down for the original. And where the second derivative is positive, where I'm concave what? Up. Then if you change concavity, what did we call that yesterday? POI, point of inflection. And what we do is we say there's a point of inflection at 2, comma, and you are going to have to plug back in to get the POI. That's what makes this assignment so long. So you're going to have to go to 2 to the third power, which is 8, light work, minus 6 times 4, which is 24. So we got 8 minus 24 is negative 16. Negative 16 plus 4 is negative 12. So that's what you would have to do. And then you're going to have to actually write out, Teo, that there is a POI at 2, negative 12 because F double prime changes what? Signs. And you're also going to have to write that F is concave down from negative infinity to 2 because F double prime is what? Negative. And you're going to have to say that it is concave up from 2 to infinity because F double prime is positive because I'm not going to allow you to just write it there because the AP exam, they're instructed to do what? Cross that out. So I got to train you. I've got to train you. All right, here we go. Number 2. That was as slow as I'm going. Are you ready? Okay, I'm going to rip through these so we can get to the longest assignment ever. All right, here we go. G prime of x is going to be equal to 4x plus 1 over x. Why is this stipulation there? You can never take the log of 0 or a negative. Okay? G double prime. We're going to have 4, this is really, think of this as x to the negative 1. So it's going to be minus 1x to the negative 2 when you take the derivative of that.
So it's 1 over x squared.
So it's really just 1 over x squared. 4 minus 1 over x squared. How many raise your hand if you got the second derivative correctly? That is going to be a point on the assignment that I think comes out, I saw 228 points. Whatever 20 times 16 is, whatever that is. I'm making it up. I don't know what it is. There you go. I think it's 20 times 16. We'll count today. We're going to know officially how much it's all going to be worth. All right, now critical values. is where the second derivative equals 0, quiet, or undefined. There is a place where it's undefined. You have a fraction. I just got done doing this in college algebra. 3 problems in mathematics. You're going to have to consider this for domain, so I might as well teach it here. Anytime you're doing domain for an original function, you always consider where you can't have 0 in the denominator, you can't have a negative underneath an even root, and you can't take the log of a negative or 0. Now, I know we're doing for second derivative, but it's the same kind of thing as doing domain. You can't have a 0 in the denominator, you can't have a negative under an even root, and you can't take the log of a negative or 0. Is there any of those 3 problems? Because that's where you could potentially get undefined. Yes, you cannot have 0 in the denominator. What's going to make that equal 0? 0. So one of your critical values is 0. Now, go back up to the original problem. Could x even equal 0?
No, you don't even need to use it.
You don't even need to use it. We lose it. So that critical value is not even going to be included. Well, the interval is going to start from 0 anyway, so when you do your sign analysis, you're going to start it from 0 anyways. So, whatever. But it's not going to be a critical value. It's not going to be a potential POI. All right, so moving on. G double prime is equal to 0. Where does G double prime equal 0? I don't know. I'm going to have to figure that out, I guess. I'm going to have to take the equation 4 minus 1 over x squared, and I'm going to have to know how to do some algebra. Okay? I would move the negative 1 over x squared over. Let's just go ahead and make it positive. How many of you agree? Okay, so we're going to have 4 is equal to 1 over x squared. I don't like the fact that x is in the denominator, so let's go ahead and do what? Multiply both sides by x squared. So we're going to have 4x squared is equal to 1. Then we're going to have x squared is equal to 1/4. Then we're going to have the square root of both sides. So we're going to have x equals plus or minus the square root of 1/2. You can throw out the minus 1. Why can we throw out the minus 1? Again, what was the domain?
It wouldn't be the square root of 1/2. It would just be 1/2.
Oh, yeah, sorry. What was I doing? Square root of 1/4 is 1/2. Sorry. 1/2. You can do the square root of 1 is 1. Square root of 4 is 2. Duh. So, no, please put 1/2. If you can simplify it, simplify it. Like, you don't have to simplify like root 8, but if you've got an exact root, please, you're not going to see square root of 1/4. You're going to see 1/2. Okay? So, square root of 1/4 is 1/2. Just do square root of 1 is 1. Square root of 4 is 2. And which one can I throw out? Negative. Now, if you have a root that's not an exact, you don't have to simplify it. Okay? Especially if it's on the first response. All right? So we got 1/2. So my only CV is 1/2. So I'm going to have 0 to 1/2 and 1/2 to what? Infinity. So here's my sign analysis for F double prime. All right, here we go. Let's test. I don't want to test a fraction, so I'm going to test 1. Is that okay with you? So 1 plugged into this, plugged into my second derivative. I'm plugging in 1 into this. I just want to make sure everybody knows I'm plugging into this one. I'm not plugging into the original. I'm not plugging into the first derivative. I'm plugging into the what? So let's just make sure you know. I'll use black just to double check, okay? So I'm plugging in 1. What's 4 minus 1 over 1 squared? Positive. So they'll alternate signs. So that means F double prime is negative positive, which means F prime is decreasing what? Increasing, which means F is what? Concave down, concave what? Up. Is there a POI? Sure, because 1/2 is included in the domain. So we'd have a POI at x equals 1/2. If I had to figure out what the point is, could I plug 1/2 in? Yeah, that'll give me 1/4. 2 times 1/4 is 1/2 plus natural log of 1/2. So it would be 1/2 plus natural log of 1/2, which is ugly, but whatever. And you would not have to simplify that. You just leave it like that. All right, let's go to the next one. We feeling good? Here we go. H prime of x. Tell me what the derivative is. I'm calling on people now. Blake, you go first. How do you take the derivative of that?
Okay, so
Derivative of e to the negative x squared. What is the derivative of e to the negative x squared?
e to the negative x squared
Times
times 2x.
negative 2x. There you go. There's my first derivative. So h prime of x, I'm going to clean it up a little bit. Good job. So negative 2x times e to the negative x squared. All right, let's go to cash. You do the second derivative. I'm going to circle that first derivative because that's going to be a point later on.
Negative 2.
What rule are you using?
Product.
Thank you, my lad. All right, so we got negative 2 times.
E to the negative x squared.
Very good. Plus.
Plus.
Yeah, I got
e to the
that.
negative x squared.
Huh?
E to the negative x squared times negative 2.
X times.
Negative 2x.
Why is there two negative 2x's?
E to the 2x.
Because one was the derivative of the exponent and one was the first function. Who did that right? So, all right, I'm going to underline. I'll help you out here. I'll help you visualize it. Okay? If this one is the first function and this one is the second function, watch. So we had the derivative of the first function times the second function plus the derivative of the second times the first. Do you see it? I've even color-coded for you.
I appreciate it.
All right, thank you. What did I always say to do when you have e to the x's?
Take the yellow.
Factor. What can you factor out?
2. Negative 2 e to the negative.
You could take out a negative 2. Good, I didn't even think about that. You could take a negative 2 out, and you can take out a e to the what?
Negative x.
You do want to do that. I'm going to take that out. Take that out, baby. All right, so that's going to give me, ooh, that's really nice. What is that going to give me if I take that out here? It gives me 1. How nice is that? This one's just going to cancel, and I'm going to get rid of one of these negative 2's, are I not? Are I not? Okay, so that'll give me minus 2x squared. Do you agree? Is that good? Hey, like me now. All right, now, we're going to take each part, set it equal to what?
0.
What did I say about negative 2e to the negative x squared equal to 0? Somebody like, well, that's a really complicated L curve, Mr. Morris. I don't care. It's still an L curve, and L curves can't equal what?
0.
Unless you shift them up or down. Is there any plus or minus there? Throw it out. 1 minus 2x squared is equal to 0. All that e stuff just went away. By the way, go back to the original problem. What's the domain for e stuff? It's always continuous, no points of non-differentiability, and the domain is what? It's like a polynomial. You love e stuff because the domain's all real numbers. It's like a polynomial. All right, so we're going to have 1 is equal to 2x squared. Okay, now divide by 2. We're going to get 1/2 is equal to x squared. Now, Mari, to answer your question, this one does not have an exact square root, so you can just leave this one as plus or minus root 1/2. That one I'm okay with. All right, let's do our sign analysis. We be rocking negative infinity to negative root 1/2 to negative root 1/2 to positive root 1/2, which, by the way, is root 2 over 2, but you don't have to do that. Right? Right? You don't have to make it root 2 over 2, even though I know it's root 2 over 2, but you don't have to do that. Root 1/2 to infinity. All right, sign analysis. Which one's easiest to test?
0.
Let's test 0 in the middle. So 0 in the middle, second derivative. Where is my second derivative simplified? There it is. So if I put 0 in, let's see this. All right, if I put 0 in here, what's anything to the 0 power? 1, and then we're going to have 1 times a negative, which is going to make a what? Negative. So that's negative. What's 0 going to make this? Positive. So we got a negative times a positive, which is a what? Negative. So we got negative, positive, positive. There's f double prime. F prime is increasing, decreasing. Remember, the second derivative tells you where the first derivative is increasing and decreasing. But it tells me where 2 derivatives away tells me concavity. So that's concave up, that's concave down, that's concave up, which means there's a POI here, and there's a POI there. I'm not going to bother finding the point right now. We'll let you do that on the longest assignment ever. All right, number 4, what is required? Quotient rule, you do it.
1 times the quantity of x squared plus 1,
Minus?
x times 2x,
Very good.
all over x squared plus 1.
Now, before I take the second derivative, I would clean this up. So what I would do is I'd collect like terms on the top. Now, you know what happens? This 1 doesn't do anything, so we're going to have an x squared. We have an x squared minus a 2x squared. What is that going to give us?
Negative x squared.
What? Flip what signs?
No, never mind, it's right, it's right.
It's right. All right, so negative x squared plus 1, is that correct?
Yeah.
Over x squared plus 1 to the second power. All right, we good with that? All right. Now, the next part's not going to be as fun. Because if you ever have to do the derivative of the derivative that you just did with product quotient rule or product rule, now you're going to have a very complicated quotient rule. It's going to be a quotient rule with a chain, which means you're going to have to factor out a least power, which I practiced yesterday with you. Here we go. F double prime. I'm going to have Molly do it. First, go ahead. Quotient rule.
Remember the tops would be 2 minus 2x.
Did you do negative 2x?
Yeah, negative 2x.
Times? Times the bottom. Now what's next?
Derivative of the bottom, so it'd be,
Minus first.
sorry,
Derivative of the bottom. What's derivative of the bottom?
2 times 2x.
No.
Oh.
Doing chain rule.
Sure, x squared plus 1
To the?
second.
Mm.
First,
First. Now times the derivative of the inside.
2x.
There you go. Times the?
Chain.
Already did the chain.
Times the top.
There you go.
I don't like this.
That's good. I love it.
Times bottom squared.
Bottom squared. So if this is to the second power, now it's to the?
4.
There you go. Yeah, this is the hardest derivative you can do. This is the hardest derivative they do on the AP exam, without a doubt. So let's go through it because that is pretty complicated. So she did the derivative of the top first. Everybody see that? And then she took it times the bottom. Do you see that? Minus. Okay, minus the derivative of the bottom, which required chain rule. Does everybody see how that chain rule works now? Times the top. Does everybody see it now? Over the bottom squared. Does that make sense? Okay. You might want to clean it up a little bit, but I don't need to, so I'm going to just factor it. So I'm going to go ahead and factor. Let's look at this whole thing. Let's look at all this here, and let's look at all this here. What do they have in common? We can get a negative 2x out. We can get an x squared plus 1 to the what power? First, because you always take out the least power. Better learn how to do this. Okay, now what are we going to be left with? Let's take, first of all, this first thing I underline in black and divide by that. So the negative 2x is going to go away, isn't it? And then we're going to have x squared plus 1 to the second. We're canceling one of them, right? Because you subtract the exponent, so we're left with x squared plus 1. Okay, so that's one of them left. Now over here, what cancels? That right here. That right here, and you're taking out a negative, which is going to make it a what now? A positive. So you have positive 2 times negative x squared plus 1, which is what's left. Could you handle that without having to clean it up? And that's still over the bottom to the what?
4.
Which is nice now because you actually can cancel one of those out now. Because this out front is times, can you cancel one of those x squared plus 1s? Darn right you can. Okay, that's going to go to the third power. So now we're going to have negative 2x times, let's clean this up on the inside. Here we go. Got x squared plus 1 minus 2x squared plus 2. So that's going to give me, I'm going to put the 3 first. Is that going to be a 3? Does that distribute that 2? So 1 plus 2 is 3. Is that agreed? Okay. So that's done. And then we're going to have an x squared minus a 2x squared, which is a minus x squared. Is that agreed? Over x squared plus 1 to the what? Third power. You know what you get good at now by doing all this stuff? You get good at taking derivatives and doing your algebra. This is why I like this longest assignment ever. Because it's going to make sure you guys know how to take derivative of basic things.
Wait, is this
Are
kind of
we
problem
starting
on
it
the
today?
exam?
Yeah.
I'm going to go Thursday, Friday, because I knew that it didn't come in this morning. I'm not going to tie up my loose end Friday. I'll do that next week. That way you can just focus on getting this assignment done by Monday.
So are we getting it today?
Mm-hmm. We're going to get through probably 2 of them.
Are we going over all of the homework?
To some degree. I wanted to get through these first 4, and these last ones I just want to talk about a couple things. Okay, any questions there? I like these first four because they got some complicated stuff in them. All right, now, when you set this, I need you to listen because this addresses something. There is one like this. Actually, there's 4 of them like this. Okay? So you better listen. Second derivative, set it equal to 0. Where does the second derivative equal 0 when you have a fraction? No, where the top equals 0. So negative 2x times 3 minus x squared equal to 0. So we're going to get 2 critical values out of that. Okay? Now I'm going to stop just a second. I'm going to stop us for just a second. Let's go back to the original problem just a second. Was there a domain issue? What was the 3 problems with domain I tell you? Can't have a 0 where? Can't have a negative underneath a even root. I don't care about odd roots. And can't have a negative or 0 inside of a logarithm. Do we have a log? No. Had a kid last hour ask me, how do you know if it's a log? That's how. Okay?
Who asked it?
Tease Brody Evenson. Okay, Tease Bevinson. Yeah, he goes, how do you know it's a log? I said, I don't know. They write the word log. Okay? All right? College algebra. And I don't give him any grief. I give him no sympathy there because he had pre-calc. So he knows what a log is. All right? If you hadn't had a log, I get it. But he's had a log. So it was fun. It was fun. He smiled. He took it good. All right. So there's no log here, Brody. And there's also no even root. What's the only thing you have that's a problem? Now watch this. You should be able to figure this out without even doing any work. X squared plus 1, will that ever equal 0? It's a parabola shifted up 1. It never crosses 0. But if you solve it, here's how you know it's not going to cross 0, because you get x squared equals negative 1. And that's going to give you imaginary numbers. What do we do? So what's the domain if this can never equal 0 except for non-real numbers? Domain is all real numbers for this. You do have one of those on the assignment. So there's no critical values I have to throw out. Good news. All right? And some are like, no, that's bad news. I want to throw them out. All right, so we're going to get, what's this one going to give you for a critical value?
2.
Oh, I don't know.
0.
It's a log. All right, negative 2x equals 0. Divide by negative 2. And what do you get? X equals what? 0. Very good. All right. All right, 3 minus x squared. Set that equal to 0. We're going to get 3 equals x squared. We'll get x equals plus or minus root 3, which I would probably know that's about 1.73. Okay? I was required to memorize that in high school. I was required to memorize all your roots up to 20, all the decimals. You had to because we didn't have scientific calculators yet. So you had to memorize them all. Huh?
Would you be taking the square root of a negative 3?
No, because I added x squared over.
It's negative square root of 3.
I'm bugging them, my bad.
Yeah. All right. Now, let's go back to this. Hold on. Shh. Is there a place where the denominator equals 0? You should settle this question quick. No, because we already did that with the domain. X squared plus 1 can't equal 0. I don't care about the cube. Okay? The cube doesn't matter. Take the cube root of both sides. All right? And it's cube root of 0, 0. So the cube doesn't matter. It's just the inside part you have to set equal to 0. We already did that with the domain. It can't equal 0. So are there any critical values where it's undefined? No, there's no place because undefined would be set in the denominator equal to 0. And we already established that when we did domain a minute ago. So the only critical values are this. So we've got negative infinity to negative root 3. We've got negative root 3 to 0. We've got 0 to root 3. We've got root 3 to what? Infinity. Okay? Boom, boom, boom. I'm going to test 1. That's why you might want to know that root 3 is 1.73. Okay? So that's going to be there. Another reason why is because the square root of 1 is 1. The square root of 4 is 2. So you know it has to be between 1 and 2. Okay? All right, so 1. Let's plug in 1. What's 1 going to give you? Here. What's 1 going to give you here? A negative. What's 1 going to give you here? Positive. So we got a negative times a positive on top, which is what? So hold on to that. What's 1 going to make this? That's going to be positive no matter what. It's a parabola up 1. It's always positive. This is always positive, no matter what. So you got a negative times a positive divided by positive, which is a negative. So we got negative, positive, positive, negative. That's f double prime. So f prime is decreasing, increasing, decreasing, increasing. That's going to be more important next week. This really all you need to do is concave down, concave up, concave down, concave up. Are these all potential POIs? Yes, because they were in the domain, because the domain was all real numbers. You would have to find them all. Yep, now you know why this is going to be the longest assignment ever. All right, rest of the homework I think is pretty straightforward. It's the same kind of stuff. All right, make sure you got through 10 done. I will, what I'll do is I'll go through the rest of those answers with you tomorrow to give people who are going for knowledgeable a chance to get those done. I'll just go them real quick just to make sure we're not missing anything. Okay, so most of you already have that done. That's great. There's a place to submit. All right, are you ready? Here we go. You need blank sheet of paper up. I'm going to start it today with you, give your partner, and then tomorrow we're going to work. Here we go. Are you ready? So, we're going to go through this process, and then after I do number one, I'm going to give you a partner. 20 of these, yes. Shot. Are you excited? Now, this is the good news. Look at this page. What you're going to like about this page, you will like this. Need one more? Okay, here, pass that back. Cash, go take it back to those ladies. Be a gentleman. All right, what you will like about this assignment. You're going to like this. Okay, you will love it. All right, every problem has to be self-contained on one page. So you're only allowed to fit one problem aside. So how many problems can you fit on one piece of paper? 2, one on the front, one on the back. Okay. Well, if you want paper, I got some in there. All right, here we go. Number 1. All right. And if you're worried about me killing trees, I've planted over 300 in my life. I've covered it.
You're pretty cool. I'm sorry, it was a bad shot. She meant it. She meant it. I think you should give her a 0 on the assignment.
That might have been the most cap thing anybody's ever done. I just sat there insulted. Here we go, number 1. I'm loving it. Here we go. I have planted close to 300 trees because my wife was crazy when we got our first 2 pieces of property. And the first time we did it, we planted like 150, and I think about 70 made it. So about half. That's pretty good, actually. Yeah, usually she'd have me water those things all summer. We had buckets with holes we drilled in them, and I'd carry buckets of water with holes in them and let them just slowly drip. I was like, golly. And then the last piece of property, if you've seen our house now, all those trees and the thing we planted. So anyways, plant a tree. But I'm cool. All right, here we go. X to third minus 3x squared plus 3. Good news. Look at this whole page. What do you notice about this whole page? They're all polynomials and rational functions. There's no trig functions. There's no e to the x functions. There's no natural logs. So everybody, the derivatives are going to be fairly easy. Product, quotient rule, chain rule, product, quotient rule. Yeah, you come get it. All right, product rule, quotient rule, chain rule, and simple power rule. All right, here we go. All right, now it says all these 12 things. I'm going to block off everything in number 1 that you have to do. So first thing, in every problem, you do have to give domain and range. You will probably do the range will be the last thing you do. It'll be the last thing you do. Okay, you've heard that saying before. All right, or maybe you haven't. Now you have, Molly. All right, what's the domain of all polynomials? Guess what? Everybody's guaranteed for at least the first 10 problems 1 point. So double bar R. Okay? So that's it. That's done. I'll block off domain and range when I'm done. All right, now we're going to go through it. We're going to do the first derivative test. We're going to do CV, sign analysis, figure out where it's increasing and decreasing, and all the extrema. Here we go. So step 1, we're going to find the derivative. All right, what is the derivative for me?
3x squared minus 6x.
Block it off. There's a point.
Oh, you got next one?
All right, every time you get to something that is an answer, block it off, okay? So, there's the first derivative, okay? Now we need to find CVs for the first derivative. So CVs for the first derivative is where it equals what?
0.
Is where it equals 0. You don't have to worry about where it's undefined because it's polynomials. So we're going to have 3x squared minus 6x is equal to 0. Can I factor it? Take a 3x out. That'll leave me with x minus 2. We're going to have two CVs. What are they? Let me ask Kate. 3x equals 0 will give me what?
0.
0. Good job. And what's the other one?
2.
2. Very good. Block it off. There's your CVs.
Oh, we're cooking now.
So far, you got 3 points. All right, now we're going to do our SA for the first derivative. I'm going to go over here to the right and do it. SA for f prime. Are you ready? So the SA for f prime sign analysis would be from negative infinity to what?
0.
0 to what?
2.
And 2 to what?
Infinity.
All right, make sure. If you miss a critical value, your whole sign analysis is going to be screwed up. And that's where you start getting points, lose points like crazy. All right, Blake, test it for me.
Okay, so plug 1 into the first derivative, which is 3 times x, 3 minus 6, so it's negative.
Okay, I kind of followed you. I did, that'd be positive, that'd be negative, positive, yeah, negative, okay, gotcha. All right, positive. Now, I do want you to label that line as f prime. Make sure you know that what you just found is the signs of f prime. You know where the graph of the derivative is above and below the x-axis. And where the graph of the derivative is above and below the x-axis is where the original function is increasing and decreasing. Where the first derivative is positive or above the x-axis is where the original function is increasing. Where the first derivative is below the x-axis or negative is where the original function is what? Now you can go ahead and, it's probably a good idea to label this so that I can write out my answer correctly. Increasing, decreasing, increasing. And you are allowed to abbreviate. Now, you're going to write your final answer. Here we go. You're going to say f is increasing. Here we go. And then this is what we'll block off. F is increasing from what? Negative infinity to 0, union, 2 to infinity, because f prime is positive, greater than 0 or positive. You can say f prime is positive or you can say greater than 0. It's up to you. All right, now we're going to say decreasing. F is decreasing where? 0 to 2, because f prime is negative. Block this stuff off. Now we need to do relative extrema. That's the first derivative test. We learned yesterday. If you haven't watched the video, watch it. First derivative test says this. When your first derivative goes from positive to negative, it is a what?
Max.
Max, because for those of you who weren't here yesterday, we explained this. If your first derivative is going from positive to negative, where the first derivative is positive is where the original function's what? Look at me. It's going what? And then where the first derivative is negative is where the original function is what? Which means that point, that critical value has to be a what? A max. And we knew it was a peak or a valley because it's where the first derivative equaled 0. So it's a horizontal tangent there. Okay? So, you're going to say that we have a relative, let's do them all. What's this one at 2 going to be? Because it goes from, watch, it goes from decreasing to what? So that's a min. Now we write it out. So here we go. We're going to say relative. You can say relative max at what? 0, comma. Oh, you got to plug it in. You got to go back to the OG. Yep, 0, 3. That one's easy. Because f prime changes from what? Positive to, you can't say changes signs. You have to say what signs it changes from. because that classifies as it a max. All right, now relative min. Now, if you have more than one relative min and one relative max, you can include it in the same statement. So if there's two relative maxes, you can list them both and then write your reason. Relative min at 2 what? 2 negative 1. How'd you get that? Plug it in the OG. 2 cubed is 8. Minus 12 is negative 4. Negative 4 plus 3 is what? Negative 1. Is that correct? Because f prime changes from what? Changes from negative positive. Now, yesterday we talked about this for those of you who haven't watched the video yet. And I went over some of the other homework too in the video. We did a lot yesterday. But some people say, can I say that it goes from increasing to decreasing, decreasing, increasing? Can somebody tell me what you would have to do if you said that? You'd have to say f, not f prime. And I usually don't do it that way because the AP exam actually encourages you to use f prime for your reason. So we're going to do it with f prime. But you could technically say that it changes. The reason 0, 3 is a max is because f changes from increasing to decreasing. It will, but they like it better when you use f prime because that's how they have their answer keys. All right, now we go to the second derivative. There we go. First derivative stuff done. Okay, now let's go to the second derivative. All right, let's come down here. I'm going to come second derivative. Let's go y double prime. 6x minus 6. That's light. Block it off. Another point. All right, CVs for the second derivative. I label everything. I mean, I'm just super freakish about this, but it's going to be where it equals 0. Now, on the AP exam, you don't have to write CVs for the second derivative. You can just set the second derivative equal to 0 and do it. So 6x minus 6, and even on my assignment, you don't have to label everything exactly like I'm doing it, as long as you got the stuff done. What is x going to equal? 1. Very good. Block that one off. I'm not going to go to circles. Okay? All right, so there's my CVs for the second derivative. All right, now my SA for the second derivative. This one's going to be nice. It's going to be negative infinity to what? 1, and then 1 to what? All right, so we're going to have f double prime. I do want to encourage you to write f prime and f for this, to write what it all means, just so you're drilling it into your brain. All right, so real quick, sign analysis. If I did 0, it's going to be negative, right? Well, obviously, this is, again, a line, 6x minus 6. Look at me. 6x minus 6 is a line going up, so it has to go from below to above. So negative, positive, decrease, increase, and then most importantly, concave what? Down, and concave what? Because where it's negative, it's concave down. Where it's positive, it's concave up. Those of you who weren't here yesterday, 2 derivatives away always tells you concavity. 1 derivative away always tells you increasing, decreasing. Now, there's also going to be a POI only if concavity what? Switches. So there is a POI. So we're going to write all this stuff down now. Here we go. So we're going to say F is concave down is concave down. What do we say? Concave down where? Negative infinity to 1 because F double prime is negative. Or you can say F prime is decreasing. They actually accept either of those because that's the true definition of concavity, is where F prime is decreasing is where you're concave down. But they like, I guess the most common way to say is because the second derivative is negative. And then they say F is concave what? Up from what? Because F double prime is what? Okay, block that off. And then POI is going to be easy. POI at where? At 1 comma original. Always the OG to get the points. That's a good question. All right, if you plug 1 in, I believe we already did plug 1 in, didn't we? No. So we have 1 minus 3 is negative 2. Negative 2 plus 3 is what? 1. So it's 1, 1. And you have to say, and this is nice because you don't have to say how the signs change. You just have to say the signs what? Because F double prime changes signs. Now that one you can just say changes signs. the original.
3 minus 6. Oh,
You plugged into the derivative. Okay. All right, are we ready? Now, we're going to make a nice, big, pretty graph. So, we're going to graph it now.
What else do we have to do? Is that it?
Was that in step 9?
That is, so how many block? Let's see, what do we got? We got domain range, that's 2 points. Let's count up here. We got 1, 2, 3, 4. I'm going to give a point for the sign analysis. 5, 6, 7, 8, 9, 10, 11, 12. Okay? 2 points for the graph, so 14 is what it was.
You don't have the range yet.
And I counted the range, didn't I? Yeah, I did the range. Domain and range are separate points. 280 points. There you go. Won't pass this trimester if you don't do this homework assignment. Okay, here we go. Ready? The graph. Shh. Ready? Here we go. Bjorn? Yeah, suck it up. All right, so here we go. And then I'll give your partners, and then we can be off, and then we're going to let you guys have class time tomorrow and some time Friday, too. All right, now here's what you do to graph it. Make a nice, pretty big graph.
Is that big enough?
Okay? That's pretty good. Yeah, this is probably the shortest one. Okay? All right. You can certainly use your calculator to check it to make sure you did it right after you're done, but don't use it. This would be expected to be done without the calculator. So if you want to kind of check in the end to make sure, golly, man, did I get it right? Plot all the points that you have. Plot every point you possibly have. Okay, what points do we have?
0 and 2.
0, 2.
Oh, 0, 3.
Yeah, I got 0, 3. Okay, 0, 3. What else do we have?
1, 1.
We have a 1, 1. And what else? A 2, negative 1. Agreed? All right, so there's what I got. All right, now let's follow the commands of your sign analysis. Okay, and where it's supposed to be going uphill and downhill and all the concavity. I'd pay attention to where concavity is going to switch first. Where's concavity going to switch? So I know I'm going to start out curved down, and then I'm going to be curved up. So I can kind of get a feel for what this is going to look like. I'm going to start out curved down, then I'm going to be curved up. So you kind of probably got a feel for what this is already going to do. So according to the sign analysis, I can't see it, but it starts out increasing, correct? And we're going to be curved down. And then all of a sudden, we're still curved down, but it switched to decreasing. So it's going to switch to decreasing, and it's going to stay curved down. You need to make it look like it's curved down still. And then all of a sudden at 1, 1, it's going to switch to what? What happens at 1, 1? Switches at what? The concavity switches at 1, 1. So now it's going to go to curved up. So you're going to switch it so it subtly has that change of looking curved up now. And it kept decreasing all the way to 2. And then from 2 to infinity at what? There you go. Nice, pretty graph. It's about as perfect as you can get. Now you'll be able to tell me the range because it doesn't peak out or bottom out, but it actually goes up and down forever. So what's the range for this one? Now, some of you could have done the range in the beginning because some of you look at it in the beginning and say it's x to the third. I know it's going to be 1 up, 1 down. So I could have done the range automatically. The ones you won't be able to do the range for are what? The even ones. The even ones. So, who is, real quick, before I partner you up and let you, I know we don't have a lot of time today. No plan to. That's why I'm going to give you tons of time. You're going to have the whole class period tomorrow. And then what I'm going to do Friday is I'm still going to give you the whole class period, but I'm going to do a couple of problems for you. Okay, I'm going to do a couple of problems for you. I'm going to do one of the absolute value ones because I always do it every year. So one of the absolute value ones, I'm going to do number 14 is the one I'm going to do. So save that one for Friday. I'm also going to do one of the bottom ones so that you have one of the bottom ones completely done with asymptotes because there's some extra stuff there because there's some vertical and horizontal asymptotes you got to include. So it's actually more than 280 points. Okay, because there's some vertical and horizontal asymptotes. Extra points I'm going to grade there for those. Okay?
There's extra credit?
All right? No. There is a slant you can do extra credit for. Okay? I don't think you want to. All right, so let's do this. Who is gone? I know Grace and Megan are going to be back tomorrow. Who's gone the rest of the week? I want to figure this out.
Is Bjorn?
Raise your hand if you're gone. Where are y'all at? Are you gone tomorrow and Friday? Okay. I'm going to let you guys work together. You guys just work together. Who else?
I'm gonna be gone.
Just when? Just Thursday. I'll give you a partner.
I'll be
I'm
on
gonna go
Friday.
just Friday.
Just Friday.
I'm gone for this.
Where are you at? Okay, so raise your hand if you're robotics. Let me get rid of that. Okay, you four, you're working together. Okay. The rest of you, is it anything else like Thursday and Friday you're going for both days? What are you?
I'll be on like half of the class.
That's not as big a deal. Okay, so everybody okay? So we need to make sure, I'm going to make a group. What I'm going to do, Teo and you, I'm going to put you in a group of 3. So that way somebody's not missing a partner. Does that sound good? Okay, so you're a 1. Ashton, you're a 1. You're a 2. You're a 3. You're a 4. You're a 5. You're a 6. You're a 7. You're an 8. You're a 9. You're a 10. You're an 11. You're a 12. 13, 14.
I thought they were together.
Huh? No, I'm going to put them in a group of 3 because they're not here the same days. So they are going to miss each other by day. So I'm going to make a group of 3 out of them. Okay? So what number did I get to? 12? Oh, yeah.
Elsa doesn't have a number.
Elsa, you're going to be... Actually, I don't even need to give you 2 numbers. So what were you?
I didn't go.
How do you not remember?
Recount. Yeah, he was 13.
I don't need a recount.
I was number 1.
He was 13 and I was 14.
There we go. You just 2 don't need number. You're 13. I'm just going to put you in a group. And then who's missing? Molly? No, Megan. Megan's missing. And who else? Grace? Okay. So I'm going to go. They're coming back tomorrow. Kristen's on vacation. Okay. So 15. She already has accepted the fact. She's like, she just said she gets to ask me questions. I said, that's fine. So Megan's going to be a 15. So Megan's going to be a 15. So 15 and 3. Who's 3? Logan. You're with Megan tomorrow. Okay?
Which was that?
She sits right behind you. Who's an 8? Who's an 8?
I'm an 8.
You're a...
No, you're.
No, I'm 8.
I'm 6.
She meant like.
Yeah, I'm always 8.
I'm 8, you guys.
Well, I'm 9.
Exactly.
Yep, 8 and 6.
You're 12.
8 and 6. There you go. Who's 12? Who's 14? 14 is Grace. Okay? So I'm going to make yours a good... I'm going to make Grace and Megan's group a group of 3 because they weren't here today.
Get out of here. I get a
So you get a group of 3. So I'm going to give you guys... I'm going to give you... Just because I know this will be fun, I'm giving you Autumn. Okay? All right?
Why?
Because
Wait, who?
You're with Logan
you're with Logan
and Megan.
and Megan.
I want to say
Logan can... No. Teo, you're going to go with Grace and Callie. Okay? All right. Who's 2 and 10? 2 and 10. 2 and 10? Okay. Who's 7 and 9? And I'll be coming around the room helping. So I'm going to be walking around. This is an assignment. I just want you to get it right. Who's 7 and 9? 7 and 9. Okay. Who's 4 and 1? Okay. Who's 11 and 5?
Yes, I do it.
Who's 13?
Yes.
Okay, I'm going to put you with Cole. This group. Okay, you're with Cole and Ashley. All right. So, any questions?